Please join me in welcoming Dr. Seth Shostak. Welcome, Seth. Thanks for joining us.
Thank you very much, Jennifer. I hope this audio is working. Can you hear
Sounds
anything?
Great. You sound great.
Okay. Well, it's really a pleasure to be here. And I can't see the audience. I'm told that there actually is an audience. What I'm going to do tonight in the next, 45 minutes or so is tell you a little bit about why we think there might be aliens out there, how we have traditionally looked for them, some ideas about how we might look for them, and maybe at the end, if you ask questions, maybe talk a little bit about what it would mean to you, the car buyer, if we were to find ET. Because I bet everybody a cup of coffee that we'll do it within 20 years. So this may be a situation you'll actually be confronted with. I work at the SETI Institute, as you can see in this slide. And SETI, it's almost my name, but that's coincidence. It just stands for the Search for Extraterrestrial Intelligence, which is in the title of this show. So this is a little different than looking for life. I mean, NASA has plans to look for life. They send rovers to Mars to do that, but also they will send flyby missions and other kinds of missions to Europa, one of the moons of Jupiter, but there's also Ganymede and Callisto. They may have life too, right? So there's 3 moons of Jupiter, Mars, that's 4, and there are 2 moons of Saturn, Enceladus and Titan that might have some sort of life. So, there are at least 7 other places in our solar system, and in fact, there are probably more, that could have biology. We haven't found any yet, but if we do, that'd be really interesting because it'll tell you right away if you find biology, under the ice of the moon Enceladus, it'll tell you right away, well, it looks like biology is not terribly rare. It's all over the place. It's just some sort of cosmic infection. But in this talk, we're going to talk about looking for intelligent life. And you may wonder what intelligence is. Maybe we'll make a definition of that, or maybe not. Now, why do we think they're out there? I mean, people will still occasionally ask me, Seth, you're looking for life in space. You're looking for, aliens. Why do you think there are any? This picture kind of sums it up. This is one of the Hubble Deep Field photos. And this is a very, very tiny bit of the sky, the amount of sky you would cover up with a pinhead held at arm's length. So it isn't much sky. But the exposure on this, I don't even know what it was, a couple 100 hours, I think. But in any case, you can see that there's all sorts of stuff. And there are a couple of stars in this photo, but mostly, almost overwhelmingly so, they're not stars. These are galaxies. Even the little dots, they're galaxies, but farther away. A galaxy is typically home to a couple of 100 billion stars. So every one of the lights, with the exception of the 2 actual stars here, represents hundreds of billions of star systems. And if you made photos like this all across the sky, something for which your tax dollars are still inadequate, but if you were to do that, you would count on the order of, several 100 billion galaxies, each with a few 100 billion stars. Okay, that's a lot of star pleasure, but of course, ET is not going to be living on a star. It's going to be on a planet. But what we know now and have learned in the past 24 years is that almost all these stars have planets. Planets are very, very commonplace. Okay, for every star in the universe, there's at least one planet. Okay, that's it. And some of these planets we've learned are at least the same size as Earth. There's a listing of all the planets found around other stars kept by the University of Puerto Rico on their website. You might check it out. And here are on the order of 1 or 2 dozen such planets that are about the same size as the Earth. And more than that, they're also at about the right distance from their star that they might have liquid water, they might have oceans and so forth and so on, even an atmosphere. So, these are planets that might be somewhat like the Earth. They could be cousins of the Earth. Now, if you're looking at the details in these renditions, well, don't. Those are just an artist's imagination. Nobody knows what they really look like. We don't even see them in most cases. We just know they're there. All right. But it is currently estimated that out of every 3 stars that are sort of like the sun, and the sun is, it's not typical, but it's pretty typical. I mean, 1 in 10 stars is the same brightness and size as the sun. And 1 in 2 or 3 of those is estimated to have an Earth-sized planet. So bottom line, there are a lot of planets out there. And if there's nobody on them, if they're all sterile, I mean, that could be, but if that's true, that means that Earth is really, really special. And one thing that we've learned in the past 500 years is that every time we thought Earth was special, we were wrong. So we're probably wrong here too. The number of planets in the Milky Way is on the order of 1 trillion. And, maybe 1 in 10 of them is sort of Earth size. Maybe 1 in 100 is sort of Earth-like. That's still an awful lot of Earths. Okay, so how do we find ET? Now, we can't go to these worlds, of course. I mean, you can go, but it takes a long time. At the fastest rocket speeds that we're capable, you could go to the nearest other star, which by the way, is known to have a planet about Earth size. And it would only take you 75,000 years. And you're probably thinking, well, I don't want to get a middle seat for that. I'm going to try and get an aisle. 75,000 years is a long ride. And, you can say, well, I'm just not going to do it. I'm going to wait until they have warp drive or something, whatever warp drive is, and not take so long. But the bottom line is we cannot go looking for the aliens where they live. We have to find them some other way. And the scheme that has been used for the past 6 decades has been to use big antennas, radio telescopes, like this one. This is the one we use, the Allen Telescope Array. It's in Northern California, even farther north than where I am. I'm close to San Francisco. These things are about 300 miles north of San Francisco. But they're called the Allen Telescope Array because Paul Allen, the co-founder of Microsoft, paid for the development of these things. Anyhow, these are used by pointing them at the direction of nearby stars and listening for signals, okay? On the assumption that if there are sophisticated beings out there, they might be producing signals either for our benefit or for their own benefit because they're communicating with somebody nearby and we happen to pick up the signals. This is some of the electronics. And we have 72 million channels these days, but there are experiments running now that have many, many more channels. So no matter where ET is on the dial, within reason, we could pick up the signal if there is one. Okay. Now, have we heard them? This is a question I get at parties, right? Well, okay, Seth, you're looking for ET. Have you found them? Well, of course not. If we had found them, you wouldn't have to attend this talk. You would know about this. This would be a big story. It'd be all over the news outlets, right? And since we've been doing this for 60 years, thereabouts, you might wonder, well, that's a little disappointing. I mean, if you went to, an island in the South Pacific where somebody said there was buried treasure, and you spent 60 years digging up the island and still haven't found the treasure, you'd probably be disappointed. Well, okay, why is it that we haven't heard anything? How do you explain that? Well, here's some possibilities. I mean, maybe there just aren't any aliens. That again, I find that unacceptable because that would make us really special. And I know you think you're special because, your parents told you that for the first 10 years of your life or something. But, humans are not necessarily special at all. So I don't buy that first one. They could be hiding, maybe they hide because they know that there are other societies out there and you don't want to draw attention to yourself because maybe they'll just come and wipe you out. I mean, that's kind of a dystopian look at the universe, but I mean, maybe it's hard to believe they're all hiding, but okay. We haven't looked in enough places. Yeah, that's where I come down. I think that the real problem is that the experiments have not been going on long enough. Yes, 60 years, but they've only been good experiments for the past, say, 10 years. So not so long. Not enough sensitivity. That's another technical problem, but maybe we just don't have sensitive enough systems to pick up their signals. That could be too. That's possible. Now, speaking of sensitivity, here come numbers. They say every time you use numbers in your talk, you lose 10% of the audience. And I have 20 numbers here. So, okay, this is just an indication for those who care about such numbers of the sensitivity of signals that SETI experiments could pick up. That's actually a very, very weak signal, in fact. But if you sort of work that backwards to say, okay, in order to get that signal, how big does ET's transmitter have to be? How powerful? Well, if that transmitter is just broadcasting in all directions, right, then they need, 10 trillion to 1,000 trillion watts. Now, that's a lot of watts, 1,000 trillion, right? And all SETI experiments have more or less the same sensitivity. They're all pretty much close to one another in sensitivity. Now, this is millions, even a billion times as much power as the the radar that used to exist on that telescope down in Puerto Rico. We used to use that, but that collapsed about a year ago. So that radar is not doing anything, but it is a lot more than the total power used by Homo sapiens. So I say total power, I mean, not just Pacific gas and electric, not just Pacific gas and electric plus your automobile, right? Plus aircraft and trains and everything, add up the total energy use factories of Homo sapiens. And it's still not as much power as the aliens would need for us to have heard them. Okay, so that suggests maybe why we haven't heard them. Now, that's so much power that, the power bill might be too much even for aliens. I mean, I never begrudge the aliens some power, but some energy, but it's a lot. It's a lot. Now, they can beat that rap, and the easy way for them to beat that rap is not to broadcast in all directions, but to decide that they want to ping, some particular star system, maybe even ours, and that they can do with an array of antennas. This is an idea for a project that was never funded, but it would have allowed us to listen very specifically in certain directions. But if we had transmitters on all these antennas here, then you could also very accurately target a transmission, right? And that'll save you a lot of energy, okay? In fact, the amount of energy that would be required if you had something like this to produce the same signal strength would, be a few thousand watts. It wouldn't be very much, okay? But to count on the aliens actually signaling us deliberately, in order for that to happen, they need to know we're here. Otherwise, there's very little motivation for them. Why would they just take a random star system and say, okay, Zork, let's spend 100 million galactic cruceros, and we're going to send a message to that star signal over there, that star system. They might do that if they thought there was somebody there who might listen, right? So aliens, I think, would only broadcast in our direction if they had already picked up, our FM radio, maybe our television radar, something from Earth that would tell them those guys know how to make a radio receiver, okay? But we've only been broadcasting the kind of high frequency signals that they, could conceivably pick up since the Second World War. So say 70, 75 years ago. So this is some idea here of the stars that are close enough to us that are all within, say, 36, 37 light years, so that these stars are close enough that our signals after the Second World War have had time to get to them and additional time for them to send a response to us, okay? That's not many stars, it's a couple of dozen. In other words, bottom line here is the aliens, unless they're on around one of these stars, they don't even know we're here. So when your next door neighbor stops you tomorrow and says, by the way, I'm being routinely abducted by space aliens, you can tell them that, it's not probable that they even know you're here, that they would come all this way just to abduct you. Doesn't make sense anyhow. Now, they might know that Earth has life, even if they're farther away, because they could measure the light bouncing off the Earth and see these spectral indicators of life. You see Venus, if you look at the light reflected off Venus, you see these lines on the right-hand side. Those are due to carbon dioxide. There's a lot of carbon dioxide in Venus's atmosphere, but that's not life. It's just carbon dioxide, right? Mars down at the bottom has some carbon dioxide, and that's about all. But Earth, as you see, has not only carbon dioxide, but it has water vapor, it has oxygen, that O2 there. So the aliens, if they adequately fund their astronomers, they might very well know that there's oxygen in our atmosphere, which is produced by photosynthesis. So that might give them some reason to broadcast in our direction, except, of course, things that have photosynthesis they don't build radio receivers, right? I mean, I don't think your backyard plants do that. So, I'm not sure that that's terribly interesting. That would be interesting for the aliens if only biology were rare. But if biology is rare, then, we're one in a 1,000 or one in a million, and we're very far away from them. Okay, now I've said that SETI experiments that have been done since 1960 actually have failed to pick up anything. And while I don't know that that means too much because of the questions of sensitivity and how much real estate we've looked at, it does suggest that maybe we ought to look at other approaches as well as continuing to do what we're doing, right? So here's a plan B. and it's this. We look for what are called artifacts. Now, this is, an artifact for the purposes of this talk, an artifact is just something that some other society has built. Okay. Now, yeah, well, why? I mean, what is it about artifacts? Artifacts are just things that you might trip across that, you don't need any special equipment to see necessarily. You might just find it when you're just studying the sky in the course of ordinary astronomical research. Okay. Now, this is somewhat of a fanciful thing, just a big ring-shaped city, I guess. But, it's an artifact. And while this doesn't look big enough that you could see it from very far away, maybe there are things that are. Remember, the universe is 3 times as old as the Earth, right? The Earth is about 4.5 billion years old, the whole solar system. But the universe is 3 times that. So there's been plenty of time for some civilizations to not just get to our level as as impressive as it is. I mean, they could be literally billions of years more advanced than we are. And if they're billions of years more advanced, what sort of thing could they do? What sort of things might they build? It could be stuff that, is completely beyond what we think of building. And maybe that's something we could find. So they may have had a billions of years head start over us. Now, there are a bunch of advantages for looking for artifacts as opposed to looking for signals. When you look for signals, you have to hope that the radio signals, or maybe you're looking for flashing lasers, whatever you're looking for, it has to be arriving at your receiver when you look, right? I mean, we look at any given frequency typically for maybe 3 minutes, and then we move to different frequencies, right? We kind of step the receivers up the radio dial. So ET has a 3-minute window during the course of a universe that's been around for 13.5 billion years. There's a 3-minute window in which their signal has to arrive. And, maybe that's asking too much. So this synchronicity problem is avoided when you look for artifacts, because, it doesn't matter when you look, they're always there. There's also this problem. Here you see Stephen Hawking, and he famously said something about don't broadcast anything. It's okay to listen, of course, no danger in listening. But if you broadcast anything to the aliens, I mean, you don't know. They might be friendly, but they might not be friendly. And if they're not friendly, maybe they, send some sort of armament in our direction and sort of flatten the Earth or wipe out Los Angeles or whatever. I mean, the aliens in the movies are always keen to wipe out Los Angeles. And I don't know whether that means that they all live in Northern California or something. I'm not sure what that means. But, you don't know whether aliens would be friendly or they wouldn't be friendly. And you can say, well, they probably are friendly. But on the other hand, do you want to bet the Earth on that? So by looking for artifacts, they don't have to broadcast anything. So from their point of view, they haven't revealed where they are. You can say the artifact reveals that, but maybe they build the artifacts very far from where they actually live, in which case maybe it's not such a problem. They also don't have to be alive now, right? If somebody told me, well, Seth, I want you to go look for pharaohs, right? Well, there aren't any pharaohs these days, right? Oh, there's some that are in a museum in Cairo, but there are no pharaohs. But you could prove to yourself that there were pharaohs by finding the pyramids, stuff that they built, artifacts. So these are all big advantages of artifacts that you don't have when you look for signals. Let me give you some of these examples of things that we thought might be artifacts. Now, this was one of my thesis advisors, actually, a long time ago. This fellow, Martin Schmidt, an astronomer, was the guy who found the quasars. 3 weeks after I got to school, the cover of Time magazine had my advisor on it. There he is. He invented quasars. Now, these are just sort of strong radio emitters. They also put out a lot of light, but nobody knew what they were back when they were discovered. And so many people said, well, we don't know what these things are. I mean, they're producing an awful lot of radio static and light and so forth. Maybe they're alien transmissions. Well, I mean, that was possible. Turns out they were not. They were due to black holes in the centers of galaxies, but nobody knew that originally. So that was an example of finding something that might have been an artifact. Okay, 1967 pulsars. Right, these were found actually at Cambridge in the UK, in England, and they were found with radio telescopes. They were sources that produced very regular clicks, if you will. If you look down on the middle of the plot there, you can see the radio intensity, and it was about once per second. You went, right, 1.5 seconds apart. Now nobody knew what they were either, and the people that where was this? This was in Cambridge, actually. The people in Cambridge called them LGMs, little green men. I mean, they probably weren't terribly serious, but they didn't know what they were, and they could have been little green men. As it turns out, they're just rotating dead stars. I mean, they're very interesting, but they're not little green men. Okay, so intelligent like me not be where it's at. Well, okay, we think of aliens. I'm going to go back to this. We've been talking about the aliens as if they're like the aliens you see in the movies, like these guys, right? They're short little guys with no hair, no whites of their eyes, no sense of humor, and small noses. Yeah, maybe they don't wear clothes either. I mean, yeah, maybe that's what the aliens are like. That's what Hollywood thinks they're like. But Hollywood has some vested interest in making the aliens look like this, because that way, when you see one of these guys up on the screen, oh, Bob, that's an alien. They don't need backstory. They right away know. But when you look at these fellas, you see that they kind of look like your next door neighbor, right? I mean, they're very anthropomorphic, right? They have 2 eyes and a nose and a mouth. They have heads, right? I mean, they have 2 arms, 2 legs. I mean, they're like us. In fact, some people would say these are kind of our unconscious view of what we will look like in another, couple of 100,000 years or 1 million years, because we're losing our hair. Hey, these guys have lost all their hair and so forth. We're getting smaller. I don't know. Some people think that that's what these are, but in any case, it's not necessarily what aliens are like. It's just somebody's imagination. Now, if you want to know what the aliens are like, well, either you have to find them or you got to make a good guess. And here's one way to make a guess. This is a plot that's due to a roboticist, actually, by the name of Hans Moravich, who is at Carnegie Mellon in Pittsburgh. And what he did is plot up these red dots are the speed of the fastest computers as a function of time, right? So, 1960, you can see how many million instructions per second a computer would be able to do. These are the top of the line computers. Now, Moravich's plot runs out of data about 2002 or something like that. And you could see that in 2002, for $1,000 or whatever, you could buy a computer that would have the compute power of a lizard, right? I mean, maybe if you're selling car insurance, that's good, but that's maybe not that impressive. But the point is, if you look at 2021 here, depending on which green line you choose, you can see that for $1,000, which is the kind of computers being plotted here, you can buy the compute power of a human. Now, you probably didn't pay $1,000 for your laptop, but within a couple of years, $1,000, for a couple of $100, you'll be able to buy a laptop that has the same compute power as you. Now, you might wonder, well, what do I do then? I mean, this laptop here, it has the same compute power, as my brain. What should I do? And I don't know what you should do. Maybe you should just turn the keyboard around and tell the computer to do all the typing. I don't know. But the point is not that those things are thinking. They're not going to be thinking machines, but the thinking machines are not far behind. They might be 30 or 40 years behind developing the hardware. That's up for grabs, but that's what I hear here in the Silicon Valley. So the point of all this is that just really at the same point where we invent radio and we build big radio telescopes, we also invent our successors. We invent intelligence that goes far beyond our own intelligence, right? And the aliens may have done that too. So the aliens probably are not biological. They're probably machines. This is a timescale argument, right? Here you see Marconi, actually, in 1900, practical radio, okay? But less than a half century later, this is during the war, we had computers. And the computers had the same architecture that, my computer here has. I mean, they weren't all that different. They're a lot slower and a lot bigger, but, otherwise they weren't that different, okay? And by 2050, this is kind of the diction I hear a lot, will have, if you will, generalized artificial intelligence. Not machines that can just play a good game of chess. I mean, obviously they can do that, but machines that can do anything cognitively that you can do. So you might think about your job prospects. But anyhow, the point is that after that, 20 years after you have a machine like that, you have a machine that's smarter than all humans put together. So I figured that ET is really probably not biological. They've gone beyond that. They've invented machines. So ET, when you think about ET, it's not going to be, one of these guys. As fun-loving as they seem, it's going to be some sort of machine. Okay, that might change the way we should be looking for them, because suddenly you don't have to look for, some sort of biology. You don't have to find a planet that's like the Earth, because machines don't need a planet like the Earth. They don't need any planet. They need a source of energy and some raw materials for spare parts. But beyond that, they could just be living in the depths of space. So how could we find this synthetic intelligence? Well, I don't know, but here's some things to think about. If you want to be able to find them, you sort of have to second guess what they're doing with their time, right? Where are you going to find them if not on a planet? And what sort of things are they doing? Well, here are some things they might be doing. I'll just go through a couple of them. First off, they could just be playing solitaire. A lot of organic intelligence on this planet spends a lot of time playing solitaire. I certainly do. But I mean, if you're talking about machine intelligence, maybe they get bored with solitaire. I don't know. Humans don't seem to, but maybe the machines get tired of after, they play a new game every billionth of a second. They might get bored. Maybe they just build big stuff. I mean, who knows? I don't even know what this stuff here does, but whatever it is, I'm impressed that they were interested in building it. Maybe they do that. Maybe they do what this guy suggests. This is Nick Bostrom. And Nick is in the philosophy department, I believe, at Oxford. And he has written articles about what he calls ancestor simulations. Now, what are those? Well, everybody's familiar with the video games, right? And some of them are pretty accurate simulations of, Grand Theft Auto experiments or whatever. I mean, you can make fairly accurate simulations just for video gaming. But he says, look, with the rapid improvement in computer speed, which is something we've already talked about, he figures that in another 20 years, you might be able to kind of simulate not just, one scenario. You might be able to simulate all the things that are going on in your world. Now, what he said in one of his early papers, which was, very provocative, he said he figured there was a 20% chance that your life, as you experience it, right? Your life, as you're sitting there, suffering through this presentation, you're not actually real. You're just a computer simulation. This presentation isn't real. It's just a computer simulation. It's all fake, right? Well, I happened to interview him for our radio show, and I asked him, I said, well, Nick, how did you get this 20% number? And he wasn't very clear in his answer. So I don't know where the 20% comes from. But I mean, this idea is bizarre, but it's not nuts. I mean, it could be that's what really advanced, aliens do. They just sit around and they simulate everything. They don't actually do anything. Maybe. All right. Well, here's another. We know that the universe, and we've seen this before, the universe is a great place for us now, but it's slowly, well, not so slowly, it's expanding, which means it's getting less and less dense all the time, right? There's less and less in the neighborhood to see. I used to study galaxies, and, over the course of the next 1,000 trillion years, there are going to be fewer and fewer galaxies that we can see with our telescopes, right? Because of the expansion of the universe. They just disappear over the light horizon, okay? And eventually, not only that, after another roughly 10 or 100 trillion years, all the stars will have died. In other words, they'll all run out of fuel and they'll turn into, in most cases, charcoal briquettes, some cases black holes, okay? Well, charcoal briquettes are not terribly interesting, and you can't make a living as a farmer if you're on a planet orbiting a charcoal briquette. So the point is that the universe is, slowly becoming colder, darker, and less interesting, right? In fact, the last thing that's predicted to happen in the universe happens in 10 to the 100th years. That's a 1 followed by 100 zeros. That number, by the way, is called a googol. But in any case, now that's obviously a long time from now, right? But the last thing that happens in the universe is the last big black hole kind of evaporates with a sort of a bang. Okay, and that's it. After that, nothing really more happens. The universe is still there. It keeps expanding, but you can't even roast a marshmallow because there's no energy to do it, and there are no marshmallows. So, but the universe keeps going. I mean, it's still going. If you're a religious person, you may ask yourself, well, what's the story of the universe then? I mean, there's a big bang, and then for 10 trillion years, there's stars and planets and, reality television shows and whatever you find interesting about life. And then eventually there's an infinity in which nothing happens. Not a long time, but an infinity. All right. So this is not intended, I should say, to discourage any of you who are looking for the meaning of life. But, however, advanced aliens may confront this and decide to do something about it, at least to postpone the inevitable. So maybe that's the kind of thing they're doing. This was the idea of a fellow by the name of Dan Hooper he's at Fermi Labs, I believe, in Illinois. Anyhow, he says that really advanced societies are going to go grab stars and bring them home, put them in a corral, behind wherever they're living, and just keep them there so that when their star runs out and becomes a charcoal briquette, they have all these other stars sort of, stacked up. It's like hoarding tissue paper during the COVID crisis, right? You just get as much of it as you can. That way you're at least set for a while. Okay, but the implication of this, I mean, I don't know how serious it is, but because there are various technical problems with it, but nonetheless, it would be easy to recognize any society that was doing this because you would just see a whole bunch of, bright stars in their corral. So that's something you could look for. There's another idea here. This is Bob Zubrin's idea. He's another very forward-looking thinker, actually. And Bob Zubrin says, well, black holes are great for getting energy out. You can get energy out of a black hole by essentially just tossing your garbage sort of in the direction of the thing, and that accelerates the garbage. And so you can take the kinetic energy out and, you've got a lot of energy. Okay. And he thinks that a really advanced society might build synthetic black holes just because of the energy you can get out of them. All right. I don't know. But then you could start looking for, the equivalent of synthetic black holes. You might say, well, how do I know it's synthetic? Yeah, that's a good question. But there are ways that you might be able to tell. And so if these things are all over the place, then that might give you a clue too. And I would just say in general, if you're going to look for artifacts, and I think it's worth looking for artifacts, is just look for things that are different. Look for things that don't make sense, that you don't understand. This is the Vera Rubin telescope under construction. But this is going to essentially make photos of the entire sky that it can see from its location every 4 days, I think it is, okay? And then just compare them, see, does anything change, right? Has something moved, right? If you see something moving, maybe it's just an asteroid, maybe it's something more interesting. There's been an experiment that was conducted by people in Sweden, actually, where they took pictures that were made by telescopes of the sky, pretty much the entire sky, and then they got a different set of photos that had been made 50 years ago, right? And they essentially just compared the new ones with the old ones to see if, did a star completely disappear, or did something appear, or did a galaxy suddenly go out, and so forth and so on. Now, it's not clear that there's anything interesting in those data yet, but that kind of an experiment, which, maybe 15 years from now you can do with your cell phone, is the way to find ET, to look for things that are really out of the ordinary instead of waiting for the signals. Well, okay, I'm going to stop talking here and let's go to questions, but just point out to you that we are looking for signals, not just radio signals. We're also looking for flashing laser lights and stuff like that, with the assumption that, if somebody's out there, they might be trying to either get in touch with somebody in their neighborhood, maybe they have colonies or they colonize some planets or something, or with us, or somebody who is close enough to us that we pick up the signal. I still think that is the gold standard for finding ET, but I just wanted, with this little presentation, to suggest to you that there are other ways we can do it, other ways that simply look for the most advanced societies in the universe and see what they've done to the neighborhood.